naturally arises in many chemical forms. Yeah.
Was the G the constraint?
Sorry, G is what?
The G the constraint?
In this case, G is the constraint, that you have to be on G equals to 0. You have to walk along the circle. Right? Any questions? You can actually plot this. I think it might be interesting. In Excel, you can just make a graph and you can see what it looks like. It will kind of give you some intuition, I think, about what it is. All right, any questions? No? How much time do we have left? 7 minutes? Okay. All right, good. All right, so can I go on? So now we're going to formalize this a little bit more. Because you can imagine that, okay, this worked very well because f was only a function of 2 unknowns, right? What if that if it's a function of 3 unknowns, 4 unknowns? You can no longer rely on this geometric interpretation, right? So we have to come up with a more formalized approach to solve this constraint optimization. And that's called the method of Lagrange multipliers. Okay? All right. So, what is a Lagrange multiplier? Sorry? I should tell you also, in thermodynamics, these constraints also happen very naturally. Like constraints of fixed internal energy, maximize entropy, right? What is second law of thermodynamics? Sorry? What is second law of thermodynamics? Sorry?
Derivative of entropy with respect to time is always
It's really third law, right? Well, second law can be expressed in a lot of different ways. One of the most obtuse way of defining it is to say, in a system with fixed internal energy, entropy achieves a maximum at equilibrium. Almost a useless definition, but nonetheless, like I said, the most obtuse way of defining it, but completely correct mathematically and physically. So anyway, you can have constraints of fixed internal energy, sometimes fixed volume, fixed number of moles. So depending on different constraints to optimize, the definition of thermodynamics changes. Like if the constraint is fixed temperature and pressure, what is the definition of equilibrium? Sorry? Gibbs free energy. Very good. What happens to Gibbs free energy? Okay, very good. Yeah. So yeah. And that's why, in fact, Gibbs free energy is the most useful free energy in some sense, because the most intuitive, physically easiest to achieve constraint is fixed temperature and pressure. Right? All right, good. So that's all. So you can go back into thermodynamics and see how you define those. And actually, the Lagrange multipliers have a very physical meaning. But anyway, here let's come back to this. At least mathematically, we only know f and g. F and g can arise from various different fields of engineering and mathematics and physics. So right now, the equation we derived was fy or fx equals to gy over gx. Right? I've removed the minus sign. Or actually, we can keep minus signs first. Okay? So then what we do is we're going to rewrite slightly differently. We're going to rewrite this as minus fy over gy equals to minus fx over gx. Okay? All I did was bring this here. Here, bring this over there. Right? Okay. Now this is called the Lagrange multiplier. What does it really mean? So if you think about it, what is fy or gy? Fy represents a slight change in f while holding x constant. Gy represents a slight change in g while holding y constant. So this ratio represents essentially the slight change in f while changing g. Right? So that's sort of the, you can think about the definition. I think it's not easy to come up with a really physical definition of, I think, Lagrange multiplier. Anyway, you define this as Lagrange multiplier, and you will see the value of this. Right now, it doesn't really make things any easier. So then you basically get two equations. So now how many unknowns do you have in this problem? Initially we had x, y, right? Now how many unknowns? 3. What's the third unknown? Lagrange multiplier. So you might ask me, why are we creating a third unknown? So Lagrange multiplier is one of those situations where the easiest way to solve the problem is to actually make it more complicated. It frequently happens. But yeah, this is a trick that you employ which really makes the problem so much easier to solve. It becomes more formal. So anyway, so now you have 3 equations. One equation is this equals to this. Second equation is this equals to this. What's the third equation? G equals to 0, right? So 3 equations, 3 unknowns, you can solve it. All right, next time you'll solve it and we'll try to solve some more complex problems.